All right, good afternoon. How's everybody doing? Good, you got your snacks, your salads, hummus, it's all good? All right, my name is Nir. I'm one of the product managers on Azure Functions and on our serverless platform, Azure Functions, Logic Apps, and Event Grid. This afternoon we'll have a very challenging session. There's myself and there's a magnificent 7 list of other presenters that are going to do demos and tell us about real use cases. So I'll try and keep my remarks to a minimum. These are a nice set of other serverless sessions we're going to have. So if this session sucks, there's always the other ones. You can try those. Cool. So how many people in the room think they know what serverless is and used it? OK. So what is serverless? You got it? Very clever slide? No? OK. So who has seen these slides? OK, so that's good. So if you compare cloud computing to transportation, when we started moving to the cloud, it's sort of like buying a car. We bought an IaaS machine from our cloud provider, but we still owned it. So we still had to make sure that the OS, where the analogy of our components of our car, is maintained. And we paid for the car even when it was in the parking lot. Then came platform as a service. That's more like renting a car, right? You didn't have to maintain, you didn't have to change the oil, you didn't have to do service, but you still paid for it when it was in the parking lot. When your code was not running, you were still paying for CPU, which is great business for us, not complaining. However, then came serverless. So that's like one of those car-sharing companies. And essentially, all you get is to run your code. We are maintaining all of the infrastructure. You don't have to think about where your code is running. And the big innovation here is you're only paying for the time that your code is running. So it's just like using one of these ride-sharing apps. It will move you from point A to point B. Cool. So why do people love serverless? You don't have to worry about the infrastructure. So you really are going with maintaining your code, maintaining your app instead of maintaining your environment. You don't have to worry about scaling. If you write it correctly, you understand how it works, it will scale infinitely for your needs. And then there's a simple programming model of functional programming. And with the stuff we have here at Microsoft, very easy development tools and inner and outer loops, which we'll see during the demos. So obviously, there's a lot of kind of hearts and no? Thought it was OK. Fine. The jokes will end very soon. Cool. So one of the things that's interesting in our industry right now, there's a lot of sort of mishmash or salad of terms. Serverless is now becoming to this term that you remember you used to say that people are cloud washing stuff. Now people are serverless washing stuff. So if you look at sort of the strict definition of serverless, it means there's an abstraction of the infrastructure. You get to scale instantly. And then you pay only for the time your code is running. What we're seeing now is we're seeing people shipping what we call FaaS, functions as a service platforms, obviously like Azure Functions, but others that are running on that serverless infrastructure. And what we're seeing emerging now is something like Azure Container Instances, where you essentially run a container with the same rules. You don't have to instantiate an orchestrator or a VM to run your container. The container will scale, and you're only paying for the time the container is up. So as things move forward, we're seeing this sort of category emerging and morphing. The other byproduct of that is we also are seeing, and we've seen this in Scott's keynote, we're seeing functions running on other infrastructure. So it's very easy to call a Raspberry Pi serverless because there's no server there. But what we're really seeing, we're starting to see this functional programming model running on in other places like Kubernetes on-prem, obviously on Azure Stack, and then in Azure Container Services or any Kubernetes or any container compatible data center. Cool. So when we talk about the Azure Serverless Platform, we are essentially talking about a bunch of things, right? So it's very nice to have compute but you need more than compute to have a real app. You need state, you need messaging, you need a database, and obviously with the intelligent edge, intelligent cloud, you need all these AI services to make sense out of the data that you're collecting with all these devices. In Azure, we look at these three sort of champion serverless applications, Event Grid that we'll talk about and we'll see, that allows you to create events at scale and connect all of these serverless applications. Logic Apps, which is our visual way to create workflows, and we'll see that. And then Azure Function, which is our function as a service product. As you can expect us as Microsoft and US developers, we have an industry-leading application lifecycle management story. You can develop Azure Functions in Visual Studio and Visual Studio Code. You can develop Logic Apps in Visual Studio. You can debug locally. And then with our integration with App Insights, you can actually look at how your application is running after the fact and understand how your application is behaving rather than doing operations to your infrastructure. And again, we'll see some of that in the demos. Excuse me, sorry about that. That was not a joke. I won't spend too much time on this slide. You're going to see the variations of this slide for the rest of this presentation, and you'll get tired of it. But these are basically just the sort of canonical use cases of how our customers are using the serverless technologies. And during the presentations, we'll try to go through examples of all of them. Cool, so until now, I haven't told you what's new in serverless. And as you know, to create these presentations, you have to come up with this really, for lack of a better term, stupid scenario where you try to tie it all together and have sort of a demo. So we're introducing nearsbumperstickers.com. It's a very exciting endeavor that myself and the team have come up with. And essentially what we're trying to do is be a data-driven bumper sticker business, right? So we're going to go and collect all the bumper stickers from all the cars that we see on the bridge in 520. We're going to find what are the most common words in there. And then our crack team in marketing is going to create the ultimate bumper sticker that will immediately sell. We already signed the term sheet, and we raised $50 million for this company. So it's very exciting. That will be my last day at Microsoft. Probably not. So to start with that, we need to go with the IoT piece, right? So as you've seen in the keynote, we are able to run some of our serverless platform on IoT devices. And to tell us more about that and announce some new stuff, I'll welcome Asavari to the stage. Which number?
Yeah. Thank you, Nir. All right. Thanks for being here today. So I'm going to be talking a little bit about languages and functions. Traditionally, you saw that functions came packed with 3 languages. You could build using C#, JavaScript, or Java. Last year, we heard feedback from you about the need to support Python, so you can then enable your machine learning and data science scenarios also in a serverless fashion. So today, I'll be showing you a little snippet or a little sneak peek into what the support looks like. So here I have a functions project and a Python function. I'll zoom into my function a little bit so you can see better. Sorry. Here. My function uses 2 bindings. You can see them described as method attributes in my function. These are described in the function.json manifest, where I have a blob trigger. So this is a trigger binding that can invoke my function. And then another output binding, which is blob storage. So my function, after it executes, it can go back and write something to storage. Let's look at the actual Python script or our actual function. And just to show you what this function is actually doing, I'll tie this back to Nir's bumper sticker idea. He's stoked about this business plan. You can see the excitement on his face almost. So what we're going to do is our blob trigger will kick off this function. We'll grab the contents of this new item that was added to blob, and then make a request to the cognitive services computer vision endpoint right here to grab the actual text that's contained in that image. Once we've made this request, we'll use the response along with the Python natural language processing library to extract any important phrases or nouns off that text. We can then go ahead and use those nouns or phrases and write them back to storage to a different container via the output binding. And you can see I'm using the easy-to-use functions programming model here and not really interacting with the Azure storage SDK as such. So that's what the programming model brings you. OK, let's go ahead and run this locally. And I'll use the functions command line utility to start my function app locally. And so once I have this, you can look, I have my function app running on a localhost endpoint. To actually run this, I need to kick off my trigger, which will be a new item. Let me just set the resolution right here. OK, I'll add a new item. Let's go ahead and pick the sticker. Looks like a cool one. So once I upload the new image, this event should invoke my function, which should process the image exactly like we discussed earlier, and output the results to a separate container right here. So I'll go ahead and open the results. It looks like I uploaded to the wrong container. Let's try that once again. And this should produce a txt file with the results, which is the actual contents of, or the text or the contents of my image. Right here. Now, this was an example of the function running on my machine locally. But the great thing about our Python support being on the V2 runtime is that you can not only build and run anywhere on any platform or OS. You could see I was developing on a Mac. But you can also containerize this function, your function and the function's runtime, to run on, say, an IoT device. You can obviously run it in any of the Azure container services. But the IoT device gives you the potential to even run it on, say, a Raspberry Pi, which is the example I'll be showing you today. So let's take the exact function that we saw earlier, maybe a slightly separate, slightly different example, in which case, instead of ingesting my image from Blob Store, I capture the image from the camera that's attached to my Raspberry Pi. To containerize this function, I will go ahead and build the Docker file that's been provided to me, and then push it to Docker Hub registry. Once I've got it on Docker Hub, I will switch over to my Pi right here. And Docker pull it. Just to save us some time, I've already Docker pulled the image to Raspberry Pi, and I can simply go ahead and run it. And so what this will do is it'll kickstart the container that contains the function's runtime, the Python language worker, and finally your function app or your Python code. Let's give it a few minutes here. OK. What I'll do now is I'll take a picture of an image I've got on my camera. Let's first start with the exactly same image that we saw earlier, so we know it works the same way, and then we can try with a few different images. Yeah. OK. Let's try once again. If only I can hold this right. OK, doesn't look like the demo gods are with us today. But I'll set this aside, and you get the basic idea, which is other than being able to run your function on Azure or in the cloud, you can also containerize it and run it in your local environment on an IoT device or a different environment, if you will. The great thing about this is now that hopefully once I do figure out how to hold the camera right and take a picture, I can go around the parking lot taking pictures of different bumper stickers and getting more data instead of just being based on the sample set that I had in Azure for market research to help the bumper sticker business.
Thank you. Cool. So we've seen the example on TechU and Savari, an example for IoT cloud and edge. As you can see, this technology has a lot of potential, and one day we'll get a demo that works. Oh, now we don't have a clicker that works. Cool. So we've seen the demo. So today we're announcing the preview of our Python support in containers on our V2, and we'll soon see that support arriving in Azure in the serverless mode. And I believe that was it the Cognitive Services Vision API, right? Savari, the Vision API? Yeah, so Computer Vision API now supports outputting a model that you've trained into an Azure function, and what it will create is the Docker file with the Azure function that you need in order to run it immediately. So that's available today. So with that, I wanted to invite one of our partners, customers, that is actually using our serverless technology for their product. So please help me welcome Ravi from ABB.
You use the clicker?
Yeah. Yeah, this one.
Thank you.
Don't press the up button, I don't know.
Good afternoon. Can you guys hear me? Hi. So I work for ABB. I'm not sure how many of you have heard of ABB. ABB is an industrial company. We're sort of like GE or Siemens that you have heard. So ABB deals with different kinds of business units. We deal with industrial automation technologies. We also work on robotics, electrification products, power grids, and things like that. So ABB is pretty well known in Europe. We do have around 35,000 employees in North America. We recently acquired GE Industrial Solutions as well. So we have around $35 billion revenue, around 135,000 people work for our company. So before I get into how we use the serverless technologies within ABB, I wanted to tell you how we are working on building a digital platform within ABB, right? So we have, as I told you, we deal with a lot of business units, and we have different kinds of devices that we build. Some of them are robots, drives, motors, or even the ships. A lot of cruise ships have propulsion engines that they run. We also build the electrical vehicle chargers as well. So what we wanted to do was build a very generic platform using which we could collect data from our devices and using which we could run machine learning or models, things like that, so that we can build some value-add solutions on top of the data, right? For example, we wanted to know before the devices fail. We wanted to make sure that we can notify the customers that their equipment is up for maintenance so that they don't have to stop their production in the factory, right? So things like, so how do we do all of this? So we wanted to build a platform a digital platform to collect the data from the devices. And not all the devices are greenfield devices that can connect to the internet. So we also wanted to be aware where we could actually have an edge gateway that could connect to the devices using any protocols that are supported, like Modbus or OPC or things like that. Anyway, long story short, so we have this cloud technology that we're focusing on, where we have one ingestion pipeline and for which we use IoT Hub. And once we get the data in from the devices, we wanted to store them securely and do certain kinds of analysis on the data. So if you can see the picture, I'm not sure how clear it is. As you can see on the left-hand side, you have the IoT Hub, which is our ingestion layer where we get the data from our devices, which securely connect to the hub using digital certificate authentication. And then they also upload the files using the IoT Hub storage that is associated with the IoT Hub. So once we get the data in, what do you want to do with the data? We want to validate the data, because your data is as good as the valid data. If you get garbage in, then it's garbage out. There's not much you can do with respect to data analysis. So this is where we use functions to validate the incoming data based on the schema that we already said this device is going to produce the data for. And we also do some kind of payload routing. So we know when the data comes in, we want to store it for some kind of analysis, which means we send it to separate storage, versus we want to use it for kind of like a hot path, where you want to make it available for the web applications. There you have a real-time updates that are happening. In addition to that, we also use the functions where from our backend, which is where our UI is, where people can send the command back to close the loop to the devices. Let's say you want to tell your device to update its firmware. Also send the location of the firmware so that the device can actually download the firmware and update itself. So we use it for the command and control as well. In addition to that, we also use the functions where we upload the files from the devices. For example, this bumper sticker kind of things, where you can actually take a picture of your equipment and then upload it from the device itself to the cloud. So when we get the file, it just lands in a generic IoT Hub storage. What we would like to do is take it and associate it with the actual device itself. So if you want to take a look at the web UI, you find a particular device. Let's say in this case it is a robot or a propulsion engine. Then you say, okay, this picture that I took is associated with so-and-so device. In addition to that, what we would like to do is we also use the functions for sort of like soft alarms. So for example, let's say the operating temperature for a particular device is anywhere between 20 to 45 degrees. And if it goes beyond that, you want to detect that condition and raise an alarm. So we use all of this, functions for all of these use cases. Now, why did we use functions, right? We could have written all this code using some kind of services in the cloud. Obviously, speed and agility, right? Because we didn't want to build a service and worry about the infrastructure. We want to focus on the business use cases rather than implementing the infrastructure to handle how to scale and things like this. So that is one of the first benefit for using functions, and also polyglot nature, right? Because we have developers that work on C# or Node.js or Java, so it gives us choices of using the right language. Another thing is it has inbuilt integration for triggers like Service Bus or Event Hub or blob storage and things like that. So we don't have to write our own code and worry about building the triggers or the syncs for that. How would we like to use the serverless technologies in the future? So right now we just started using functions, but we would still like to look at other use cases as well. For example, logic apps is something that is pretty new. So this is something we want to use for our integration with enterprise applications. So it's right now we are so much focused on IIoT, but we also want to expand this to do an enterprise integration as well. Also some kind of social media interaction as well if there are applications and needs for that. And we're also exploring Event Grid. Right now we use functions to move the files around, and Event Grid could be a good use case for us there. In addition to that, we also have the IoT Edge gateway use case where we'd like to use the functions there so that we can actually filter most of the data before we send it to cloud, because sending the data to cloud is not really cheap. Yeah. Thank you.
Thank you, Avi. So you've seen how we're advancing this use case in IoT and how people are actually building products with it. Another use case that we see a lot with functions is obviously, or with our serverless technology, is microservices. It's very easy to build these HTTP endpoints and get applications up and running. It's very easy to use our API management or API proxies to create a nice REST API on top of functions. And we're also seeing use in data integration, where you have to process data that's coming in from different formats and essentially clean it up, just like Ravi was talking about. So if we continue sort of our sticker journey, we'll talk a little bit about durable functions. Durable functions is a set of capabilities we have on top of Azure Functions that is there to solve sort of practical problems where you still need state or you need to run a process that takes more than the 5 minutes or 10 minutes timeout that most of the fast providers give you. So the first one is obviously very simple. I need to call function F2 from function F1, and I need to have some kind of a serial process. The other one, which we'll see in our demo, is a bit more complicated. I need to fan out and fan back in. We'll see that in a second with our sticker demo. Another sample we're seeing is HTTP endpoint. So essentially, it's very common for us to say we need to run an asynchronous process, right? We call some kind of a web service, we put something on a queue, something else processes it, puts it on another queue, because we don't want to create a DDoS attack inside our system. With our HTTP API, it's trivial to create an endpoint, and that endpoint will provide us with the data to see how our async process is running. And we'll see an example of that in a moment as well. Another pattern that's very common is monitoring. So I have these jobs that run on a scheduler, but what if the job fails? What if the next job that will initiate 10 hours from now is actually looking at unfinished data from the previous job or something got corrupted? With durable functions, I can actually change my timer based on how the first job went, which is very powerful for all these kind of huge batches that I need to run. And then finally, I can do a long-running workflow where I can have human interaction. I need to change states on some kind of process, and I can use the durable function to wake up a process many, many days later. So the main point is that we have something that is stateful. The programming model is very intuitive. It's the stuff we used to in C#. And let's sort of connect it to our sticker story. We've successfully collected a bunch of sticker text from all these sources. And now what we want to do is essentially figure out what are the most common words inside the stickers. So that calls for the very classic pattern by now of MapReduce, right? We have to open all these files, gather all the words, and count which are the most popular. So for that, Katie is here on stage to tell us a little bit more about durable functions.
Okay, great. Thank you, Nir. Which is the button to switch over to my machine?
Which one?
Which button switches over to my machine? 7.
7.
Perfect. All right, well, thank you all for coming. So what I am showing you today is the next step in our demo. Now that the part of Asavri's demo, where she has pulled all the visual data out of the bumper stickers, translated it into text, pulled out the relevant phrases, and put that up into blob storage, we're going to take that and we're going to analyze it. And we're just going to see what is the most popular what are, say, the top 10, 15 most popular words that we're seeing on our sample data of bumper stickers? And so to do that, we need to go through each file, look at what's in each file, and take up a count of the words. Doing that sequentially is going to take a while. If I have 10,000 files and I want to open them all one by one, that's going to take me a long time. So here is a good use case for durable functions. What we're going to do is use what Nir referred to as the fan-out, fan-in pattern. And you can see I'm in Visual Studio right here, developing locally. And I'm using a very familiar API. I'm using the Task Framework API to schedule each one of those file openings as a task. So we'll take an activity function. That activity function will open up the file name that it's given, and it will pass that data back to the orchestrator, and it will become part of the local state. We can aggregate that and use We can use task.whenAll to wait on all those tasks. When they complete, we can take that total all of the data from all of the files and run it through a function to calculate which words are the most common out of those, and then output that. So in this local test, because as much as I love my Surface Book, it is maybe not quite up to 10,000 files or so, I'm going to run this on a test case of 10 files. So let's start this up. You can see I've got a breakpoint here. So when we hit this line, we'll be able to breakpoint into Visual Studio. You have that experience as part of developing durable functions locally, the same way that you have for developing any other type of Azure function. One thing that I should mention, we're going to kick this off with an HTTP trigger. So I've alluded to a bit the orchestrator and the activity. Durable, an activity function is basically the functions that you're used to. They perform some sort of work. It can be async, it can do I/O. And then Durable introduces this new concept called the orchestrator function. And what the orchestrator function is a runtime that's not starting, and I bet I know why. Yep. Kill that one. Okay. Now live. Okay. So the orchestrator is used to literally orchestrate the actions of various activity functions in code. It's kind of like logic apps in that it allows you to define a workflow of various pieces, but you can do it in a code-based fashion. So if visual designers aren't for you, then that's what Durable Functions does. Okay, so we have started up. We've got an HTTP endpoint to kick things off. I'm going to note that an orchestrator function can be kicked off from any type of trigger binding available in Azure Functions today. I just like to use HTTP triggers because they're pretty simple to set up, and I also get some nice JSON back with endpoints. And those endpoints will allow me to monitor, those endpoints will allow me to monitor the status of what's going on in my orchestration as it runs. So let's kick this thing off. Give it a second here. 2 seconds. 5 seconds. There we go. All right, so this JSON that I've gotten back, you can see I have this status query get URI. And if I follow that, I get some information on the status of my orchestrator as it's running. Now it's currently running through a number of files, so it may be a touch slow to respond. Oh, and it's actually already done opening up those files, or at least scheduling the tasks for them. So we're going to take that breakpoint out and let it continue to run. And in the meantime, we should get some information back about what's going on. Sometimes I run this, and by the time that I've queued up a new window to query the status of what's going on, my job is already finished. In this case, it looks like the status request is taking a lower precedence than all of the I/O activities that are going on. Let's just try. Oh, there it is. All right, so we can see that our function is running. We didn't put in any input, and we don't have any output yet, but we will when it completes. We get a created time and a last updated time. And I'm actually running on a slightly outdated version of the extension, because in the general availability release, which is one of the things that we are announcing, is the general availability of durable functions, I can also add in a custom status to give me more information about what my orchestrator is doing as it runs. Let's check in on this again. There we go. Okay, so we can see we've gotten some words here from my sample data, and it looks like there were a couple of actual image files in there that it doesn't know what to do with. But you can see that I've got the words other, car, my, Azure. Not even going to try to pronounce that. Microsoft, is, of, and baby. So that's doing that locally. I can also do this up in the cloud at a greater scale. So I have set up this single-page application, and all it's going to do is it's going to call the durable endpoint the same way that I did locally, but I've now written a little JavaScript code to use those endpoints that I've given back to parse the status and give it to me in a graphical format. So let's run this off, and we can give it a second, and there we go. It's pending, and now we'll start to see the history appear. I said, well, there we go. Okay, So this is going to start going. I've got about 100 files in this blob storage that I've prepared, so it should start running through there. And at the end of this, when everything is done, I will have written out a text file into this container, most used words, that will kick off a portion of the demo to happen later in the talk. So we can see that I can use durable functions to develop locally. I can use it for more complex workflow patterns, define things in code, and I can perform things at scale. Yeah? Great.
Thank you so much.
Thank you.
Thank you. 5. Yep.
5?
This is the one that says PPT. Yep, sorry.
Oh, that would make sense.
Yeah, Okay, so we've seen what we can do with durable functions to process a bunch of data. And again, we see that happening with real customers. So today we are announcing the general availability of durable functions in C#. And we're also having durable functions now available in Node.js, in JavaScript, in preview, which you forgot to show. But yeah. Yeah, but we'll also check out our documentation, and you can see how it runs in JavaScript. And actually, the work we've done to make it available in JavaScript will allow us to make durable functions available for more languages much faster. With that, I wanted to move on to data integration. Did I miss the? Let's see, I think we have a scheduling malfunction here. Oh, okay. Cool, so we'll do the logic apps, and then but just a second. You can come up, John. All right. We'll just switch, yeah. There's a model, so, we do it. All right, so to talk about the data integration, and you can set up, I have a couple of slides more. We have John up here. Today we're also announcing our partnership with the Cloud Events. This is a CNCF initiative that starting to create a standard serverless eventing format. The format is pretty intuitive. You basically have this header that has a very kind of known set of keys, and then you can bring your data based on your application, and it will help normalize stuff like webhooks, which is more of a standard rather than a format. There's many companies that are involved in this, so it's going to be supported by some of our partners. And then everything you see right now is the providers inside Azure that already support this format to Event Grid. So we have a bunch of stuff that you sort of get for free, as well as other products that can use the Cloud Event format and use Event Grid to essentially send messages with high throughput and with high reliability and be consumed by these serverless processors. And with that, let's figure out where we are in our sticker odyssey. So now that we have the words, we know what are the most popular words. And now we have to kick off some workflows to figure out how to actually produce stickers out of those. So with that, I'll hand it to John.
OK, thanks. Right, so one of the things that Scott showed in the keynote this morning, I'm going to dive into more details here, is some Event Grid integration. So Event Grid and Logic Apps are the other two parts of our serverless capabilities in Azure. Scott showed it in Slideware because we only finished it on Friday, and he asked for the slides on Thursday. So I'm going to show you like new bits that are literally just released over the weekend. It's still rolling out globally, so it's in all the North American regions. But let's sort of start at the beginning. So here I am just in the Azure portal. I have three things here. I have the storage account, which Katie was writing files to as she processed all these bumper stickers. This massively parallel job where she can handle thousands of bumper stickers. So now I want to kind of consume that and do something with it. And if you notice on the slide, there are two things that I'm going to do with this. I'm going to visualize it. I'm going to push all this data to Power BI, and I have a nice blank Power BI dashboard here with nothing on it other than a beautiful background. And I'm going to take the file that Katie generated and process over every single one of the words in that file, send it to Power BI using a streaming data set using Logic Apps. And I'm also going to, if I detect any words that I don't like in that stream, I'm going to use some of our other cognitive services, the content moderator, and push that out to my team site. So just a good example of how easy it is to do this now, and this is all the new bits I was just mentioning, is that here on the left-hand side, I now have this events tab, and when I click on this, I see a new experience where I can actually choose one of three pre-built templates for Logic Apps, allowing me to just click through and create a Logic App directly from these templates. I can also create an Azure function. I've got more options. I could go and actually create a webhook that was hooked up to the events that are coming in, or use storage queues or event hubs or a hybrid connection. So in this case, I'm just going to take this one here. When a new blob is uploaded, seems appropriate because that's exactly what Katie's been doing. So when I click on create on this thing, it's immediately going to take me to the Logic App designer. And there's a couple of things I need to set up first. There's just two connections. I'm using two data sources. So this morning, I think Jeff mentioned there's over 200 connectors for Logic Apps now. So I'm obviously using blob storage because that's where the events are coming from. And I'm using Event Grid because that's how I'm getting the event. So I can just click continue on this, straight into the designer, and just give it a second. I can open this up and see that it has passed across, my subscription is passed across, my resource type, the storage account is passed across the resource name, and I can even filter down on the actual event I want to receive. So I can say one blob created. And this is one of the changes we've literally made in the last couple of days, and these templates haven't been updated yet, is that I don't need this condition anymore that says, hey, what type of event is it? I want to filter out the deleted and just focus on the created, but it doesn't matter for this. So I'm just going to have a delay of 30 days, which may be a little long for us to wait. So let's change that to 1 minute. Save that down. And then I'm going to delete the blob, getting the path of that blob from the event and delete it after a minute when the blob arrives in my container. And that's it. I can save this straight away. It's going to open up a blade and ask me for a name of this thing. I'm just going to pin it to the dashboard. Let's call it new Logic App. And that's it. I've just created a Logic App that's going to consume the events that get fired when new files get written to blob storage. Okay, let's look at a slightly more interesting examples. I'm just going to let that sit there and create. I'll just open up this second Logic App. And this one is going to do a couple of other things. It's going to fire off the same event, so I can say, hey, when events occur on my storage account, and I can even use advanced options, and I can say only this container, most used words, because that's the output container. I can scope this up or down and trigger on any scope, either on everything in my blob storage in that storage account, or narrow it all the way down to a container. I've also got a suffix filter, so I can just narrow it down to text files that get written into that folder. So I have a lot of control over which events I'm interested in, besides just the event type. You can see this Logic App's a lot simpler because I don't have that condition anymore, because I'm filtering right there on the event type in the first place. I get the blob content, and then I'm going to for each over all of the words in this blob content. Now, what does it look like? Let's just pop across. This is the file format that Katie was using. So I just have a whole bunch of words, car, serverless, Azure, and it counts the number of times that those words appear in all of those bumper stickers that were scanned earlier on by a Savory. So what I need to do is I need to kind of break that up somehow, because I've just got this JSON document. And because Logic Apps understands JSON natively, I can use a parse action, provide the JSON schema, and the JSON schema then tokenizes all the data values in that incoming file and allows me to then pick each word and spin over them. And this is the content moderator. Now, one of the things I was mentioned earlier is that a lot of our cognitive services are highly configurable now. You can take the computer vision, you can give it your own model and train it with your own images. And the content moderator allows similar control. So here I'm using a custom list ID, and I can specify the actual terms that I want to filter out as words that I'm not interested in. This is kind of called the profanity filter, instead of using some profanity here, which would be hilarious, right? But I do work for Microsoft and intend to do so tomorrow. I'm just going to show just a couple of terms that were thrown in. You see, you can see where I'm going with this if I just click on these things. So I kind of, if you're interested in these two things, you're probably in the wrong building. So I'm just going to filter that stuff out. And if I see those, it's actually going to kick it down to the second path, which is to push it out to my team site and say, hey, this word's detected, please triage. If it doesn't have any of the words that I have in my content moderator filter list, it's going to send it out to my Power BI streaming data set, and it's just going to send out the word and the count and visualize it in Power BI. Okay, so the only thing I have left to do now is actually run this thing, and I can simply do that. So actually, because I now have two logic apps, if I click on events here, oops, I didn't enable it. So you can see this is the one that I created from the wizard experience where I just pick the template and creates it. So I can see each subscriber to the event publisher, which is the storage account. So let's just pop over and enable the logic app I just showed you. And then they should both be registered. And then I can go to Storage Explorer and open up my most used words, which is the container that I'm using. You can see Katie's, some of her previous runs are there, but I'm going to upload the file I just showed, put that in, stick of words, upload. File appears, so I can then have a look at what's going on in my logic app and refresh this, and with any luck, it should fire my logic app. There it is at 3:31. Logic apps is great because it has all this run history. I can open up each one of these and see what it did. We keep this for 3 months. You can actually increase it up to a year now as well, so that you can have very long-running logic apps over a long period of time. And acting as a sort of debug history as well, I can open it up and look at the data and see the path that it took through based on the data that it was processing, if the Wi-Fi cooperates. Ooh, tick, tick, tick. Interesting. Let me click on another one. Okay, so what's kind of interesting is that it shows there are 13 words in the file, and I see the for each loop where I span over each word in that file and made a decision about which direction I went in. So I can open this up and look at this condition. You see the condition's false for the first word, and I can just sort of flip around all of these and sort of, I'll keep going until I get to one that's true, and you can sort of see this in action. See every single one of them is going to my Power BI streaming data set. I'll show that in a second. I just keep going. Eventually I'm going to get to one that says true, hopefully, which is this one. And this time it's gone down this left-hand path and showing post message. And look, it picked one of the words that I had defined in my content moderator list and sent it down the other path instead of sending it to Power BI. And so if I go over to Power BI and just refresh this data set, I should see a nice kind of word cloud of all the words coming in from all the bumper stickers that were all processed through Katie's parallelized durable functions MapReduce job. Okay, and the only other thing is that I pop over to Teams, I should see there are 2 words that were written out to Teams based on the conditions that I had in my logic app. Thank you.
Jeff is next. Cool, so we've seen how easy it is to take this data and then write workflows, write business events. We didn't need to learn all these APIs to call stuff like Teams. We can use logic apps to articulate our business process very quickly. So today we're announcing the Cloud Event integration. It's over there in the CNCF website, and Event Grid is one of the first providers to support it. And then you've seen the new UX that allows you to create events on your storage accounts and consume them directly into logic apps or functions or other things like containers or webhooks. With that, we wanted to bring up Vikas from Starbucks to tell us a little bit about how they're using our serverless platform to build their business processes. Thank you. There you go. Yep.
Cool.
All right.
Hi, I'm Vikas Vinavalli. I'm the application developer. I'm from Starbucks Coffee Company, but my mind is kind of stuck up on the real-time text-to-speech over there, and I haven't been really following the presentation because I was trying to catch errors over there, and it's able to pick up my accent too, so that's good. So today, I'm going to talk about the inventory hub. It's the name is kind of obvious. My peers are also around here. Otherwise, I would have said this application was primarily built by me, but they're over here, and they'll probably call me out on it. So the main purpose of this application is we read this application processes all the items that a store gets, and also the number of items that we sell, or it also determines what are the items that we need to prepare in order for the customers to buy, returns, and it does a lot more things. But my main goal as part of today's presentation is I want to give you a very quick insight into our on-prem applications. We do a very good job of keeping up to date and sticking up to the current standards. And also I want to point out the components or the similar components that we found on cloud and how we have migrated from using some of the for example, I would give a very brief overview, and maybe you guys will get the gist. We do a very good job with our automation, and we believe in the policy of infrastructure as a code. For our on-prem systems, we use SaltStack, and obviously everyone uses Jenkins, and that's how we automate our infrastructure deployment. So we wanted to follow the same pattern for our cloud deployments too. And as expected, we are using Azure CLI because many of us are into Linux-based systems, and we are comfortable with CLI over PowerShell. And also we use Node.js to do some kind of complex, I wouldn't say there's complexity in deployment, but there are a lot of conditions, and based on the conditions, we do certain types of deployment, and that's where the Node.js comes into play. This specific application, as the name suggests, we do get a lot of messages, a lot of data. So a synchronous model is probably not very feasible. So in our on-prem system, what we do is we use Kafka, which actually does the queuing for us. But this application, when we built it in cloud, we wanted to find a similar component, and currently we are using Azure Event Hub. We also use Service Bus, but that's because we wanted the message timer functionality. We are big into containerization. So for our on-prem systems, we use Docker. And also we use Kubernetes, and we use Kubernetes to orchestrate our Docker containers. Initially, we started primarily using only Azure functions, but we came across the Azure container instances, and we immediately changed directions. One of the reasons why we changed directions is because we are a huge components of domain-driven design. We prefer and we believe in event-driven design too, and also we wanted to manage the distribution of the load too. So that is when we've decided, for our business scenario, using Azure container instances makes sense for this specific application. When it comes to the data store, for our on-prem system, we were using Postgres. As part of this project, we wanted to try the NoSQL world. So we were looking for a database which would suit our needs. We also wanted our database which could be which could be scaled easy, and it could be like accessible from anywhere globally. And that is one of the main reasons why we've used Cosmos DB. And also the failover functionality is pretty slick, where we didn't have to do a lot of setup. With the click of a button, it does the failover for us. We do use Azure Functions too, but we primarily use Azure Functions to sync some of our on-prem data to the cloud. We did have some issues with, I wouldn't say issues. Initially, when we used Azure Functions, we were using HTTP triggers. But the amount of load that we had, we felt it's more appropriate to use Event Hub. So we kind of write the on-prem data to the Event Hub, and we have those event triggers, which is listening of these Azure functions. And in the end, we use Power BI, and it's a pretty neat tool that we're using. We use that to track variances. This is like a very brief architecture of our application. The ones on top is probably like it's our on-prem system feeding in data to the event hubs, and we write the data to the event hubs, and we have those Azure container instances. In the event hubs, we have like almost like 20 partitions, and we have these Azure container instances listening out of like a predefined set of partitions. And also we have the business logic, which does something when the messages do expire. And there you can see in the end, we are writing it to the Cosmos DB. We do have like an active and passive. So in case of like a global, like a major disaster, we do have something to rely upon. These are some of the issues. It did work really well for us. Just lately, we started getting this client timeout exceptions. So we added this retry logic because we could get this client timeout exceptions because of like multiple reasons. One thing is the Cosmos DB, the request surges. Like for some reason, like running simple queries, sometimes it consumes lots of RUs, like Microsoft Azure portal suggests that we need to bump up our RUs. But at some point of time, like you feel that the amount that it wants us to bump up is probably like prohibitively expensive. But for the application that we built, it works really well. It's just that when we try to integrate with our BI platform, it does have some request unit surges. For the Azure functions, initially we had this issue with scaling with HTTP triggers, and we migrated to Event Hub. One of the main purposes that we wanted to achieve by migrating to cloud is because we did not want to be in a business of managing our servers, managing what versions they are on, running the upgrades. And we, like as a team, what we did was we primarily moved to PaaS, and we started using these serverless components, and it did enable us to focus more on solving the business problems than working on the infrastructure-related issues. Thank you. Just FYI, there's a Starbucks booth, and if you guys have any questions, we'll be glad to answer your queries. Thank you.
Thank you so much. Thank you. Cool. So don't worry, we're almost done. We talked a little bit about microservices earlier. Another topic that we're seeing people using functions for is single-page web applications, is the ability to essentially host your HTML in Azure Storage or on top of Azure Functions using our proxies, and then building simple web applications that consume these microservices as HTTP APIs. So let's talk a little bit about our Azure Functions HTTP scale. Basically, right now, we're at the point where we figured out what the optimal sticker looks like, and we'll find out in a moment, I'm sure. And now it's time to sell this sticker. Obviously, it was a mega hit, and we need to handle scale in our HTTP API we use to sell our stickers. With that, I'll hand it off to Jeff.
Thanks so much, Nir. All right, so we have done data collecting, Raspberry Pi picturing, logic app processing, intelligence to come to the conclusion that if Nir wants to become a millionaire overnight and have a unicorn business, we need to sell a bumper sticker that says, "My other car is an Azure function." So I'm using that data, and we've created this simple store to enable people to come to this website. They can add items, maybe 1, 2, 3, 4, 10 of these bumper stickers to a cart and make a purchase. But we had a few challenges when making this website. Now, I think this is a phenomenal idea for a bumper sticker, but I don't actually know if any of you want to buy it. And so how much do we need to scale out this back end to make sure that if people do come in here and have an email address of email@email.com, how many resources do we need on the back end to be able to process these requests? So this was the challenge that we had. So how this website actually works is it's a single-page application written in Vue. This is actually a sample from one of our community advocates, Sarah Drasner. I'd recommend you checking that out. And I have this backend completely using Azure Functions. So whenever anybody places an order, what it does behind the scenes is it calls an Azure function. Now, you heard some talk about how Azure Functions with HTTP scalability wasn't optimal in the past, and that was something that we observed, and customers like Starbucks let us know. So I want to show you some of the improvements that we've made in the last few weeks. So this is a live streaming metric of an Azure function in the back. Okay, so this is the Azure function that's processing orders for these bumper stickers. And I can actually see that right now, I only have a single server hanging around back there in some Azure data center, and it's processing 0 requests per second. So there's no traffic right now, not a single purchase. Also means I'm not paying anything to run these Azure functions. Now let's go ahead here, and I'm going to run a load test. I've got a simple application here on my laptop that will actually push 1,000 orders every single second to this Azure function. And I want to know what happens when I go from no orders at all to now everybody at this conference wants a bumper sticker and they all place an order at the same time. And when I do that, I'm going to switch back here and I want you to keep attention to the number of servers that I have behind the scenes. So let's go ahead now. We'll start that load test. Start sending off as this initializes up, 1,000 requests every second. And what you'll notice here as we watch this actually happen live is that very shortly, in the number of a few seconds, I now am at 2, 3, 4 servers that are running in Azure with my Azure function code, processing these orders behind the scenes. In fact, as I stay on this view for a little bit longer, you'll see that 5, 6 servers are coming. There's a little bit of a delay here, 7, 8. Very, very quickly, this simple application processing these bumper stickers has now scaled out to almost a dozen servers now running all processing my function code, enabling me to have very bursty traffic without having to compromise on user experience. So it only took me a few seconds. There's a bunch of instances here, and you can see I'm pretty healthily processing all 1,000 requests every single second in my Azure Function app. So that was just something I wanted to show quickly, one of the improvements that we've made to enable you to use Azure Functions even for these instant and high-demand workloads so that you can know that you can just write the code you want, publish it to the cloud, and have it process at whatever scale you need. So thank you so much.
Thank you, Jeff. So that brings us almost to the end of our bumper sticker journey. Today we are announcing the App Insight integration by default. So what we've seen showing us this real great streaming data is our product called App Insight. Up until now, you had to enable it in order to get it running. Now it's enabled for all of your function apps by default, and it takes part of our free tier, so you don't have to pay for it until you have to pay for the functions. Also, our monitoring UX, which has had some challenges being based on a different storage and performance-wise, is now based on App Insights. So we're going to see refreshed UX there, and some of these graphs will now go directly into the Azure Function UX. Cool, so one more thing. So one thing that we've seen throughout the day is that people are using serverless, and they're using it to build real applications. With real application comes things like monitoring, and also, obviously, the aspect of security. I'm very excited to invite a partner from a company called PureSec, which will talk about serverless security specifically, and talk about the beta they're launching with us today. Oi? Which number? 6?
6, but starting with the slides.
Okay. Oh, good.
Hi, so my name is Ori Segal. I'm the CTO and co-founder of PureSec, the company that develops the world's first serverless security runtime environment. And I'm here to talk to you about how you secure Nir's bumper sticker business from getting hacked. Let's start. So in general, when we're talking about serverless security, we're referring to application security. And in general, I'm sure you probably know that the function as a service provider, or the serverless provider, in this case, Microsoft Azure, is responsible for securing the underlying infrastructure, everything you've seen until now, from the regions, the availability zones, the locations, the compute, the database storage, and so forth. You are responsible for securing your own functions, your source code, which you obviously own, and that is where PureSec concentrates on. Now, if you think about serverless and serverless functions specifically, they are probably the least secure link in your chain. The reason is that up until today, you didn't really have any kind of serverless security solution, and we are unveiling it right now. And so if you look at traditional application security solutions, specifically web application firewalls, runtime applications, self-protection, host-based intrusion prevention systems, they're all focusing on securing the application layer by being installed or deployed on the network or on servers. However, in serverless, you no longer have any access, or you're not in liberty to actually install anything on the network, on any servers, or on the platform. And so in serverless, any kind of traditional application security solutions that you used to deploy up until today is pretty much inadequate or unsuitable for that case. Earlier this year, we actually published a guide called the Serverless Security Top 10 Most Common Weaknesses. You can download it from our website. Let's quickly talk about what are the risks, what is the threat landscape when talking about serverless applications. So the classic scenario, you have an event that triggers the function, which then interacts with some cloud APIs, generates output. So how can an attacker actually exploit this? And I'm switching for a moment just to show you an example related to Nir's bumper sticker business. So here's a bumper sticker that will pretty much hack Nir's business. I'll go back. And now let's be serious. So how can an attacker actually manipulate an application like that? So there are three ways. The first is to inject, as you've seen now in the bumper sticker example, to inject malicious data into the event data, any kind of field. You can also manipulate third-party libraries that the developer is using with malware. Or you can compromise one of the other components, the cloud services like blob storage or something like that. The bad things that can happen, obviously injection-based attacks like you've just seen, SQL injection, cross-site scripting, path traversal, and so forth, bypass of authentication, compromising data, denial of service, and et cetera, et cetera. So how do you protect serverless functions? Obviously with the serverless security runtime environment, which is what I'm here to show you. And what is a necessary? So a necessary is a trusted, secure execution environment that allows you to make sure or give you confidence that the functions are really doing what they were designed and they were supposed to do. It provides unparalleled visibility into the function's runtime execution environment so you can actually investigate security events in a very granular manner. It provides behavioral protection against unknown attacks. It's not signature-based. And it provides end-to-end security starting from when you actually develop your project. You will see it provides static analysis capabilities. It is cross-platform, so you can use it. You can deploy the function with our security locally. You can move it to staging, to production from one cloud provider to another. And it's very, very lightweight and high performance. We're talking about latency numbers ranging between microseconds to single-digit milliseconds. So PureSec's Tesseract is the world's first SSRE, and it actually starts, as I mentioned, when you build your function. It analyzes each and every function in your project for vulnerabilities and for misconfigurations. as the function gets invoked, it actually surrounds the function with a perimeter, a firewall, that then inspects inputs and outputs to the function. And while the function executes, it runs the behavioral engine that looks at what the function is doing and tries to understand whether the function is doing what it is expected to do or whether it's doing any kind of malicious things. And obviously, all the data going out of these integration points goes out to App Insights and to Splunk and other DevOps tools that you probably use. We are GAing this product in July this year. We're already obviously starting the beta today. And let's see a quick demo. I have a couple of minutes left. I'm doing this myself. OK, so let's start with actually trying to hack. So I have a few very simple functions here. I'll just show you the source code. The integration point of the PureSec security runtime protection is through an import of our library. So here you can see Node require PureSec. I also have this in C#. So you're loading the PureSec code. And that's basically it. That's all the integration required. So let's start attacking my functions. The first thing I'm going to do, I'm going to send my function just normal user input, name equals whatever string I want to send, and it sends me back. If I call myself Ori for that matter, it will say hello Ori. And now if I'm a smart attacker, the first thing I'll try to do is try to do a SQL injection attack. So I'll do something classic like tag union select password from the users table. And let's see what happens. So as you can see, the PureSec firewall component triggered on this malicious input. Sorry, I'm doing it again. And it's flagging this as a SQL injection. Now, the data can come now, it's coming from an HTTP event trigger. It can come from blob storage or for any kind of other event. It doesn't necessarily have to be HTTP. It could be an IoT device for that matter. Now, if I'm an attacker and I understand that there's a firewall involved here, I'll try to manipulate the payload a little bit. So we'll try another classic one, or 1 equals 1. That's a classic blind SQL injection. We'll try to fool the PureSec firewall, and it still catches. I'll be a bit smarter than this, and I'll do something a bit more challenging for the firewall. So this is obviously Boolean tests that I'm running here, and it's still detecting the SQL injection. However, if I try to type a sentence in English that looks like a SQL injection, let's see, maybe I can force this to do a false positive. So I drop table users and execute xp cmd shell dir. All really, really bad words. Most web application firewalls would trigger on this. However, I can already tell you that the PureSec firewall really analyzes the input, understands the context, and will not trigger just because there are a few bad keywords in here. We can continue with some cross-site scripting. I already pre-prepared a payload here. And you can see that it's triggering cross-site scripting. I can try something a bit different. Let's try to reach a file outside of the root directory. And it should trigger local file include. And it does. So that's those triggers that you're seeing now are the triggers generated by the firewall component that inspects the input as it goes into the function. Now let's try something a bit different. So my function will actually execute a command that I will give it, like a shell command. In the case of something legitimate, I'm going to run the vol command, which gives me the volume name of the drive. It will take a few seconds. Now, if I'm an attacker and I'm smart, I want to try to maybe concatenate a second command and run netstat, which as an attacker I'm interested in doing. And let's see if this fools the PureSec behavioral engine. So as you can see, the vol command still ran. However, for the second command, I got an access denied. That's because behaviorally, this is not acceptable for me to do, and obviously for the function to do. And how much time do we have? 1 more minute. So last but not least, I want to show you something, a little bit of UI. So this is the PureSec dashboard showing you how many functions you have, how many of them are protected, the total execution time, total attacks. And you can see in Splunk all the events. So as you can see here, we're seeing all the firewall events, all the attempts to attack that I just did, a lot of behavioral information, execution environment data, sorry. Connectivity to the internet from inside the function, so I can tell whether the function was leaking data to the internet, was it doing any kind of TLS activity. And last but not least, it will actually chart the connections and the interactions of the function during runtime. So you can see here, let me increase the size a little bit. I had 2 executions here. The first was legitimate, so Azure was calling the functions executable, and then that was launching command, which is what I did originally. And then if I inject some attempt to leak data for the internet, you can actually see how this looks like. So Azure called the runtime that called command, ended up executing some malicious command and leaking data to pastebin in this example. That's pretty much it.
Yep.
And of course, there's the last slide.
Yeah, thank you. Yep.
So we urge you to join our beta. This is the URL, and you can sign up. It's free. Thank you.
All right, thank you. All right, so we ran out of time, so I'll save you these other slides, but serverless for real. These are the things we announced today. We have a booth in the expo, so please come visit us and ask more questions, and then come to one of these other sessions. And thank you so much for your time.